Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 6 is equal to 144. So to solve this, I'm going to first start by taking the power of 6 on both sides. So I get x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So basically, I can switch the places of these two exponents. So that's what I'm going to do with x to the power of 6 and 6. So now I get x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. And 144 is the same thing as 12 squared, so I get x to the power of 6 to the power of x to the power of 6 is equal to 12 squared to the power of 6. So now this turns into x to the power of 6 to the power of x to the power of 6 is equal to 12 to the power of 12. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 6 is equal to 12, and if I take the 6th root on both sides, I get x is equal to the 6th root of 12, and this is positive or negative.